Hello, it's the 12th of June, 2015, and this is episode 10 of the Unseen Podcast. We made it into double figures. This podcast is the unedited, unscripted, uncensored, and open participation spinoff of the WOW Signal. To learn more about the WOW Signal, go to wowsignalpodcast.com. To learn more about this podcast, go to unseenpodcast.com. You can also follow us on Twitter at podcastunseen. Now, tonight we have with us David Grigg.
Hi.
Hi, David. And as you guys probably know, David is from Australia. And we have James Garrison from Oklahoma.
Good evening, everybody. Or good morning to David.
And Patrick Festa.
Good evening, good morning, or wherever you are.
And with us for the first time tonight is Andrew Boyter.
Hi, good to see you guys.
Andrew Boyter. Who is Andrew Boyter?
That's a good question, but probably not as interesting as a lot of people might hope. I am a writer and a podcaster. I live over in the mountains of North Carolina, so over here on the East Coast. I live in a little town called Boone. I got my master's here at a school called Appalachian State.
Oh,
and yes, that pronunciation is important.
Yes, I know both Boone and Appalachian State. My nephew went there.
Oh, good deal. Yeah, it's a good little school. It's a great place to go to school. Got a master's in public administration. And I am now doing nothing to do with that, so that's about how education goes. But yeah, so just I think that's the vague outline. I'm married, have a wife, have a son on the way, coming in late October. So
wow, so you and James have something in common. You both have babies on the way.
Oh, good deal! Congratulations.
And to you.
Thank you.
So I thought people that listen to this podcast didn't reproduce, but
well, we'll see.
I am wrong about that.
It's out.
Certainly. Okay, so that's our panel for tonight, and tonight we're going to talk about cool space stuff. There was a discussion about talking about Europa, and this week, NASA announced that they are planning for major missions to Europa. You guys read anything about that?
I caught a little bit of it. It came out during my work week, so it's a little hard for me to end up having to use my weekends to catch up on any kind of news.
Is anybody else?
I have learned that they chose the 9 instruments, 3 of which I think I can mention. The others, I don't remember the technicalities. I think Paul, you might be able to tell us more about them.
Yeah, well, I'd have to refresh my memory as well, but yeah, go ahead. Yeah, they've chose some instruments for an initial probe to Mercury. So, James, you don't have a tornado warning, do you?
Not currently.
Okay.
That's actually what I was looking at.
That's kind of par for the course around your neighborhood, I think. But
yeah, so we just, it's Oklahoma. Basically, we just all go sit down on the front porch and watch them.
See, here in Maryland, we'd all hide in terror.
I don't live near a trailer park, so I've got that going for me.
Yeah. Okay.
But no, it's not supposed to be that severe tonight.
Good. So anyway, Europa. Why Europa? Anybody want to speak up on that?
I'm like sort of very interested in this because me being just a science enthusiast, even though my lower third has seemed to have disappeared again, I find it fascinating. For example, the idea that Europa apparently has a saltwater ocean. I mean, that automatically, in the science fiction mind of most science fiction lovers like myself, automatically invokes thoughts of giant squids and octopi and all that stuff. It really, we're talking about a saltwater ocean.
Did you see the movie Europa Report?
Yes.
Yeah. Okay.
Well, that
no spoilers now. No spoilers, because a lot of people haven't seen it yet. But
yeah. Well, real scientists say that. Well, we can't say that. We're going to look for life. We're going to look for microbes and stuff like that. It still invokes the idea that there may actually be this sort of thing out there. We don't really know, but obviously it's the old follow the water, and we're talking about following the salt water here. So I'm very excited about this mission.
Yeah. So really,
go ahead.
I was just going to say, as far as your question goes, as far as I can tell, the only reason that Europa has drawn so much attention and so much focus in this field is it's got water, like lots of water, as far as we know for now. And that's what these missions are trying to look at. Obviously, I think this week's news was that they were announcing multiple missions. Is that right?
Right. Yeah, they announced the instruments a couple of weeks ago, I believe. Yeah. Now, I want to point out to our audience that none of this has been officially funded by Congress, and the initial funding that it will require will be small, but then the amount of funding we're talking about eventually is going to be very, very large. So things like the James Webb Space Telescope are going to have to get finished before this can happen, and that's a 2 or 3 years away before that funding profile starts to drop off, because the amount of money we're talking about is very large. However, I think NASA maybe, they're going to have a hard time funding this and a mission to Mars, but I think the mission to Mars is a little further out. But so NASA's budget has really not increased in 30 years. Mm-hmm. It's increased very slightly in non-real terms, in terms of total dollars, but in real terms, it's actually gone down. And while they'll get some European help here, it won't be a ton of money involved. So Congress is going to have to they're going to have to go to Congress hat in hand and say, look, this year we just need, a little money to study things and plan things.
Can I sort of ask a rebuttable question? As far as I know, this planned mission to Europa a budget has been approved, and that's why they chose their 9 instruments. Well,
the budget, no, the budget gets approved every year, right? So, which is kind of crazy. It's kind of irrational to plan things like this year by year, but that's what happens. What's been approved is a small amount of money to go ahead with the preliminary studies. These things are happening on paper and are happening in computers. No metal is getting bent. No hardware is being built. No flight software is being written. David.
I saw a live feed from NASA with the 9 instruments being chosen and the reasons for them. And one of the instruments that was being argued about was because of power consumption reasons was the radar. I thought that was already. Am I mistaken? I thought that was decided.
So the problem with these budgets, like you mentioned, Paul, one of them is the year-to-year thing. The other problem is the president's office. Office of Management and Budget is actually they write the budgets. They don't get approved until Congress approves them. So the president's office proposes these budgets, and then Congress approves them. So that could theoretically still be cut from the budget that Congress approves.
Yeah, I don't think we've actually had a budget in a long time. We've had continuing resolutions which it's really difficult to get a budget together. But the problem you get into here is, the amount of money that they need now isn't very much. Everything's on paper. Like the power consumption's on paper, right? The radar radars do take a lot of power. Everybody knows that. I just got my most recent mission before my current job was a weather radar that actually 2 Japanese weather radars that on a very big Earth orbiting satellite you would never get something that big around Europa with any of the launch vehicles we even have on the books or in planning, and a lot of power. But Andrew's right. What we will get this year is studies and what they call pre-phase A, which is NASA goes through a bunch of phases. They have pre-phase A, which is where you study the study. Phase A, which is where you study. Phase B, where you actually go and design things. And then phase C and D, where you build and integrate. And then finally phase E, where you operate and launch. We're not even to phase A yet. So that's an orderly process. It's an expensive process. It works for NASA, but it takes many, many years. You have to kind of understand where we are. Now, you guys might remember the Space Exploration Initiative or the Vision for Space Exploration. All those things were enthusiastically pushed by the administration at the time and then failed because when it came to actually paying for it, the money wasn't there. But on the other hand, the space station got built, and it was very expensive. So the idea is we're not going to be building a space station. We're going to be building a big rocket, but that's part of the plan. And we are going to be building. We're not going to be building a big telescope, which is what we're doing now. It's costing a ton of money, and that's. They're hoping to fill that, and we're not flying a person to Mars, or persons to Mars, right away. It's going to take longer. So, in that gap, you can do the Europa mission. That's where the big funding balls will come from.
Paul, the Europa mission that's being proposed, though, is just an orbiter, isn't it? It's not even an orbiter of Europa, is it? It's another probe in the Jupiter system. We're decades away from a lander, I guess. Would that be right?
Yeah, I think so. Yeah,
and the story I got was that it was going to. They literally know how many times it's going to orbit Europa. It's like 45 times or 40 something times, and they have all the instruments planned, and they got the mass spectrometer chosen. They've got the radar, which they finally decided on, even though it's power consuming. They said it's going to be solar powered. Which is the reason for arguing about the radar. And there's a bunch of other instruments, including the ones to fly through any water spouts or plumes, a vapor plume. I was under the impression that there was an X amount of dollars applied for this for the year 2020 something, and I'm a little confused right now because
Congress has not allocated any money for that year. Congress. At best, Congress will allocate money for fiscal year 2016, and then we have to come around again at fiscal year 2017 and get more money, and so on. That's the rhythm everybody in D.C. plays by. That's the drummer, right? October 1st of each year is the beginning of the fiscal year.
And they can't bank any money because whatever they don't spend, they're like, well, you didn't spend this much, we can cut your funding by this month.
Oh, they play games with that, but you're supposed to spend your money. If you don't,
can we talk about what? Sorry,
go ahead,
can we
David.
talk about what these? Can we talk about what these instruments are meant to find out about Europa?
Sure.
mean, the funding is interesting enough in itself, I suppose, but the real interest is, what are we trying to find out about Europa? Why is Europa fascinating, and why do we want to send a mission to Europa? Can we talk about that a bit, do you think?
Yeah, well, let's talk about why. Okay. And we talked about, Andrew mentioned there's a lot of water there. It's really a biology mission, isn't it? I mean, that's really the driver. It's an astrobiology mission.
Yeah, but you just can't say that you're going to just look for life. You've got to give other reasons. We're going to study, the tidal forces. We're going to study, see if it could be a possible resource for future exploration deeper into the solar system. If you just go, we're going to go look for life, they're probably going to just look at you and put you in the corner with the little pointy hat.
Well, the other two instruments my layman's way of knowing about are two cameras. One is a black and white, one is a color, and we're talking about distinct mapping, I guess, in order for future landing sites and stuff like that.
Yeah.
Which obviously this is not a landing thing. One of them, the resolution is multitudes better. And during the live video cast of this NASA thing, somebody had asked the question about the new technology of the cameras, and the resolution is the person. I'm sorry if I don't remember the NASA person's name. Said basically it blows everything we have out there now out of the water. We're talking a couple of centimeters per pixel resolution on one of these cameras, and I don't know which one. The other one was 2 meters or 20. It was like far different, but they were both highly resolution in comparison to anything that we've got now. So we're talking about mapping. We're talking about studying the water plumes, and of course, I only know of these 3 instruments. That's the radar and the 2 cameras. So the other 4 instruments, rather,
okay.
9?
Well,
So
the Europa imaging system, which is the imager that will be developed just up the road from me at APL, which is the Johns Hopkins lab. That's they're saying, let's see, that's 50 meter resolution, which is pretty good. 50 meters is way better than they have from Galileo. See, they have a mapping spectrometer, which is from JPL, which is somewhere out in the West Coast. This instrument will probe the composition of Europa, so they're going to know what's on the surface. They want to know how deep the ocean is. Well, that's something called the Plasma Instrument for Magnetic Sounding, and that's also at APL. And that's they're trying to measure how deep the water is and how much salinity. There's a thermal imaging system, which is basically an infrared. So I think they're looking there more, not so much for pictures, but they're looking for seeing where there might be vents or plumes. There's a mass spectrometer. There's an ultraviolet spectrograph. And there's a surface dust mass analyzer, which is looking for, stuff that got shot out in plumes and fell to the surface. So, yeah, I mean, what they're basically looking for here is details about what's on the surface and how it got there, and also below the surface what the ocean looks like. The radar, which is from the University of Texas, it's supposed to penetrate ice and characterize the crust.
Isn't one of the big questions how thick the icy crust is?
Yes, that is a huge question.
Richard Greenberg, in his book Unmasking Europa, talks a great deal about this. He's very much a proponent of the idea that there's quite a thin crust, relatively thin crust of ice, and he's suggesting that the cracks in the surface are probably key targets for any mission looking at the possibility of organics, because if the crust is relatively thin, then you would expect that those cracks actually have been opening up to the ocean, and may well actually have residues of things that are down beneath the ocean. So if there are organics, then those cracks are probably the target area to go for.
Yeah, that they're looking specifically for what they call hotspots or cracks. Could be geysers or cracks, because you're not going to get through 100 kilometers of ice, I don't think, with any kind of technology we have now. But if you could get through a few kilometers of ice, or slush, or something like that.
But see, Greenberg's point is that those cracks, which you can see have browny material coming out of them, those cracks are the portals into the ocean below, and therefore that's where we should be looking first, rather than trying to drill through ice.
Right.
Well, the question I have is, doesn't Europa rotates on an axis, correct?
Sure.
It's
Okay,
tidally
locked
to
to Jupiter.
Oh, it's tidally locked?
Which means it's rotating, but it's rotating once per orbit.
Yeah.
Okay, I understand now. Now, given that the tidal forces coming off of the home planet are going to be rather extreme, it's going to warp the planet. Wouldn't the positioning of the cracks alter as it goes around, especially when it's got gravitational interference coming off of 62 moons Jupiter's got?
It's got a lot of moons. I can't remember the number, but
yeah. But as it goes around, there's going to be gravitational influences coming off of them too, which will affect the gravitational pull.
Yeah, there's little doubt that the cracks migrate. Yeah, I think the cracks do migrate, but they don't migrate fast. They migrate slowly over a very long time. So I think
it's those tidal forces which create the heating that leads to the liquid water. And it's the same tidal forces that make Io such a full of such volcanic energy.
Yeah.
But I think there is a question, isn't there? Besides the tidal forces, isn't there a question? Actually, aren't they questioning? I should say, to put it that way, whether or not Europa has some geothermal activity at its center in order to heat up the water to cause any plumes. In other words, it could be tidal forces. Indeed, it's tidal forces that are causing the geothermal mechanism. But don't they think that actually has some geothermal things going on within the core?
I'm not sure I know what you mean. I mean, yeah, the tidal forces heat up the water. That's why it's liquid. But
not put enough pressure on there to blow out the plumes, which are going up, they go up several kilometers.
Yeah, well, think about it. There's lots of ice on top of it. That's very heavy. You're pushing down on a lot of liquid. It's going to want to rise. So if it gets through a small crack, it's going to rise fast and potentially go up, and just like a geyser on Earth. It gets hot and it goes shoots up. Now I don't know if it's how hot it is, but it doesn't have to be that hot, right?
Just warmer than freezing.
Yeah, it has
that's
to be.
True, but I think there was actually a question, and it's not something that's been confirmed or anything like that. I think there were actually, again, I'm just a layman in this, but there was and I'm sorry I can't provide the actual article or the video. There was actually a question as to whether or not it has a heated core that is contributing to the geothermal activity. To geyser.
Oh, you mean like the Earth has a hot core? Yeah.
Right, and I think the hot core would have been caused not by so much by gravity, but more by the tidal forces. But nevertheless, there was a question as to whether or not how thick the ice is, and the thinner it is, the more heat there is being provided, and that's why there was this question of this geothermal thing. Is there anybody who knows more about it than I do?
The only thing I would say is that if there's a rocky core, then of course it is just as subject to tidal forces as the water is, and therefore it would be heated up. The tidal forces are enormous because of Jupiter and the other large moons, and you only have to look at Io to see what can happen when it really gets going.
Yeah, well, let's see. Europa is quite a bit lighter than Mars, and Mars has pretty much lost all its internally generated heat. And they're about the same age, so you would expect that if Europa had any heat other than generated by tidal forces, it would be gone by now.
Well, does Europa have a magnetic field similar to Earth?
Jupiter has a huge magnetic field, so I think that's going to dominate over there.
Well, I was just thinking part of Earth's magnetic field is generated by our core.
Yes, that's true. I don't
So
think...
if Europa has one, then
I don't remember the whole story, but the reason why they decided that Europa does have a magnetic field is, or rather, excuse me, the other way around. The reason why they decided that Europa has a saltwater ocean is because of the magnetic field.
Yeah.
And it was the salt water, because it's a conductor of certain electromagnetic fields and electricity and stuff like that, that they figured out. Again, I'm just a layman, so I'm trying to explain it in my limited way. From what I understand, it was the reason why they decided that it was salt water was because of the magnetic field that they measured.
Well, it's magnetic variations, really. Europa has no magnetic field that it's generating internally, but Jupiter has such an incredibly strong magnetic field. And see it, and Europa as well, and is just inside it. It's orbiting within the Jupiter magnetic field, and so the salt water in there will conduct currents, and currents will be induced in the salt water. So you should be able to measure that in the magnetic field, but if you have a good magnetometer, you're measuring very carefully. And I think that's one of the instruments they're carrying is a magnetometer.
Okay, I get it now. Yeah, I think it was Galileo before it finished. Measured with its magnetometer some variations and it caused them to decide that it was a saltwater ocean. I think that's the way.
I'm looking at Richard Greenberg's book at the moment, and he does talk about that. Galileo had a magnetometer which picked up electrical currents basically flowing through Europa, and that led them to think that there was an ocean. Yep.
Yeah, and I think that makes sense. And
do they have an idea of what salt is? Potassium chloride, sodium chloride, or just that be found out when they get the spectrometer up there?
Yeah,
I'm not sure they're going to know exactly which salt it is, but there'll be ions in the water, which is what causes that kind of conduction.
How certain are we about the plumes? They were detected by Hubble, is that right? But they haven't been seen since. Is that correct? Or?
I don't know. Anybody heard anything recently on that?
No, the most recent thing that I saw was a couple months ago, saying they're still trying to figure out, are they intermittent, are they constant but really weak most of the time? There's just not I don't think there's any confirmation.
Yeah, I don't think. Yeah, Hubble has seen plumes, but we don't know how common they are. Mm-hmm. And I think that's. And of course, you can't get Hubble. You can't get the Hubble to stare at Europa all the time. That's not going to happen.
Whereas Enceladus definitely has plumes because we've seen them.
Yeah, Enceladus plumes are pretty much constant. And in fact, I was trying to get an interview with Carolyn Porco to tell me about what they're trying to measure at Enceladus. I'm not sure she's going to get funded this year, but in fact, the Europa mission is one of those things it's going to eat all the money if they really get behind it. So we may not see an Enceladus mission for some time, but
the thing about Enceladus is that it's tiny compared to Europa.
Yes,
if you actually see the two sizes on the same screen at the same distance, there Enceladus must have a relatively tiny ocean compared to Europa. So Europa is probably a better prospect, I suppose.
Well, the thing is, Enceladus, we know we're going to get plumes to fly through.
Yeah, true.
You wouldn't even have to really time it that well. You just fly over the tiger stripes, and there's going to be something there you can grab. And you don't even have to land. You just have to have some kind of sample gathering capability.
Raise the butterfly net, right?
Right. So essentially, yeah. And we don't know what would be in those plumes, but if you could find organics in the plumes or something else, you could have a major finding there. Now, this Europa mission is not a life detection mission. It's meant to be a reconnaissance mission for Europa. Characterize the moon very well before the next step. It's a very careful, cautious approach, similar to what's been done with Mars.
Yeah, I mean it's kind of a viability test to see, is this worth exploring further? Is there enough there that we can see that it would be worth going back?
Right.
And also, I think wisely they chose a couple of cameras. I think mapping is very important, and I've also realized that on their video cast, people keep asking about the search for life. It's actually very difficult. From what I learned as a layman, it's very difficult to actually look for actual life without going there yourself and putting it under a microscope. You can look for the organics. You can look for all these signs of life. I mean, we all know that the idea that there's an ocean of water means that there's got to be life there. That kind of attitude, of course. But for a scientist to say that, he has to have actual proof of the actual life. So instruments don't give you, the design of instruments. From what I understand, again, from a layman's term, I want to remind everybody I'm no scientist, but from what I've gathered from the scientists that I listen to, it's not easy to make an instrument to say, yes, this is alive. It takes a human eye to look at it under a microscope to actually say that, yes, this is alive. So we can look for organics and things like that. Is that am I summing that up right, Paul?
That's right. I think look at Mars. I mean, we tried to send life detection missions with the Viking landers, however many decades ago that is, and we got ambiguous results. And we haven't since then even really made the attempt to detect whether there's currently life on Mars, which of all places you would think there ought to still be life if it ever arose.
Yeah, we're a lot closer now, I think, with the Curiosity rover, but we're still, you're right. There's no direct life detection equipment on Curiosity, as there was on Viking. And
the first thing we may have would be a robot with a stick that pokes something to see if it jumps.
Well, what they did on Viking was actually incredibly sophisticated and complex. It was it was sort of the last hurrah of the Apollo generation. It was a very, very difficult instrument to build. But what they did was they mixed various nutrients with Martian soil and tried to see what came off.
Kind of like a chelation experiment. Try to see what they were able to filter out of it or get to come up.
Well, they just measured the gas, the evolved gases. Now, Mars, the Curiosity rover has an evolved gas experiment, but it doesn't doesn't mix it with nutrients or anything like that. So what they did is they found some gases in some of the experiments. And there are people to this day who will say that was evidence of life on Mars. But the scientists concluded, no, it's too ambiguous. It must have been some other chemical reaction that we don't understand. After all, the Mars soil chemistry's got to be really weird because of all the radiation. So, they decided that it wasn't evidence of that. But, well, and I say they, I mean that was sort of the mainstream conclusion. Not everybody agreed. But now,
if I may,
yeah, go ahead.
I'm sorry. I thought you were done. If I may give the sci-fi lovers side of this, and me being the science enthusiast, again, I want to reiterate that I understand how they can't say, no, this is not life, and that's perfectly normal for science. But when you see, for example, the beautiful pictures of obvious dried up riverbeds, I mean the sedimentary rocks, the Mars lander itself landed at the tip or the bottom or in the center of however it is that you call it at the alluvium fan, which is a river delta. When you realize this, I don't know about you, but as a science fiction lover, at least, it excites me. I know it might have been a couple billion years ago that this planet was as wet as we are, with all these rivers flowing and stuff like that. But it's got to excite you. That's got to say that there had to be life there. I know it's not scientifically correct to actually say that until we actually look under the microscope and see it. But for heaven's sakes, I mean, pun intended. It's like we're looking at. They actually took a photograph of a Mars dried up river with the rocks, and they compared it to the Arizona dried up lakebed, whichever it is, and you couldn't tell the difference between these two things. And they colorized it so they look kind of the same. I mean, it's like to me this is very exciting.
There's no doubt that there was water on Mars, and quite a lot of it. All the evidence shows it. There was a time when Mars was very wet. That still doesn't mean that there was life there. It's possible, but water does not equate to life.
Well, I believe John Carter was on Mars in the late 1800s.
Oh yeah.
If only we could get there his way, sort of sleep in a cave in Arizona. That's a great way to go.
I happen to know that was all done on a soundstage in Hollywood.
Yeah, well, it would have been.
Or so they want you to think.
Yeah.
That's what they want you to think. Yes.
I just finished that novel a couple weeks ago, so that got me on the brain.
The Princess of Mars.
Yeah, great stuff.
And turned into a movie called John Carter.
Mm-hmm.
Yeah. Well,
actually turned into a movie called Star Wars.
When I was a kid, I loved Edgar Rice Burroughs. Everything he wrote was great.
Yeah. He's a bit racist, but yeah, it's good.
It's just amazing he went from. It's just amazing he went from Tarzan to Princess of Mars. That's the thing.
Let me tell you, you don't want to go back and read Edgar Rice Burroughs. He's great when you're 12, but when you're any older, it's terrible.
Yeah, I think I've already got all I could out of that.
Yeah, you just got to know what you're getting into. It's a product of its time.
Yeah.
So.
Mm-hmm.
Well, Mars. I agree with David. We don't know there was life. There was definitely a lot of water. You see that in the Curiosity mission. Everything they look at looks like there was water there at one point. Just every time they turned the camera. Now you remember. I don't know if you guys know, but late last year I interviewed Nora Nofke, who's a scientist at Old Dominion University, and she thought that quite possibly there was evidence of microbial mats in some of the Curiosity images. She's an expert on microbial mats. She's seen them all over the planet, this planet, and both fossil and live ones. And some of the earliest evidence of life on this planet was microbial mats. Now, that has not been fully accepted by the members of the Curiosity science team, especially the ones who may have missed it. There's still hope that we'll find fossil life on Mars. I don't know about. It's clearly not a planet that has a lot of life on it now. If it has life,
we don't know that. We don't know that though, because most life, even on Earth, is microscopic. It's bacterial. We wouldn't see it.
Yeah, but
it's macroscopic life is going to be very rare. Anything you can see.
Even planets that have, but even if you have microscopic life, it has macroscopic effects.
Yeah, sure.
We don't see that.
The real question is, if there was life once on Mars, would it have died out? I mean, life is so adaptable that if there was once life there, even if the planet dried out and there's ultraviolet radiation and all sorts of perchlorates in soil, would it have died out? Life is so adaptable, I don't think it would have died out. So if there ever was life on Mars, it ought to be there now.
It may be subterranean, because when the atmosphere was ripped away from Mars, when it became bombarded by cosmic radiation, anything that did survive, even the extremophiles, would probably had to have gone underground, probably below the reach of any of the probes that we've sent up there so far. They could be 20, 30 meters down. They could be farther down because, as you dig down farther on Earth, once you get like if you're up in the tundra, once you get down past the permafrost, the temperature rises up, and then, you hit a point where it's relatively comfortable. So any sort of organisms, be it, unicellular, multicellular, probably would have had to have gone underground to survive. And if there is life on Mars, it's probably had to evolve along a subterranean route.
Sure.
Well, that's my entire point of what I've been saying the last three things I said. In other words, the fascination that I have with the idea that Mars was wet, the idea that Europa has a saltwater ocean, it's just fascinating. I half expect them, when they finally do land on Europa sometime in the 2030s or 40s, I half expect them to find, like giant squid running around. It's, I mean, I know it's a funny sci-fi joke, but in reality, for example, they recently found actual wet sand on Mars. One of the pictures they took, and it turns out that even though the temperature is below freezing, the soil and everything is salty, and I'm not saying necessarily sodium chloride, but in the salts, so that when the sun shines on it, it literally melts, and they found wet spots on the sand. So I mean, we're talking about possible water, even if it's just barely there on Mars. So it's still somewhat wet. Of course, there's the radiation thing killing off the life and all that. But the whole idea about life itself being diligent, it seems like life finds a way. It just seems to me that the original idea that the scientists had about follow the water is still a good one. I still think it's legitimate and rightfully so.
I agree. I just don't think you can say because there is water there is life.
Right. I mean, obviously, scientifically speaking, we can't say that because that would be a breach of procedure. In other words, to the layman, it just seems
it's
so
confusing.
obvious.
The necessary and the sufficient, right? I mean, we think that water might be necessary for life. We don't know that it's sufficient for life. The one planet we know that has life for sure has water, and lots of it, and we think the life probably started in the water.
Most life is actually, the life is fairly confined to certain areas. There's microbes in the extremophile area, but you look at multicellular life, for the most part, like humans are restricted to a very narrow band of the planet in terms of being comfortable. Fish, with a few exceptions of, lungfish and a few walking catfish, fish are confined to a certain niche. Everything has their own niche. And even if we land on Mars, we land on Europa, we may not find that one narrow niche that is actually capable of supporting and having some form of a living organism.
I just don't think. I talked about this a couple of episodes ago. I'm of the belief that macroscopic life is very rare, so I don't expect to find it elsewhere in the solar system. But I do expect that there's a chance of microscopic life, even if it's come from Earth.
I agree with you. I mean, right now in our solar system, there's only 2 planets that are habitated, and one of them is completely by robots that we know of.
Well, it's microscopic life.
Yeah, well,
but that's not life, though. Come on,
I expect wherever you've got a flux of energy, sufficient amount of free energy, chemistry will organize itself and will organize itself in ever increasing hierarchies to exploit whatever's there. Now, we've talked about macroscopic life because we're used to on Earth, but it could be colonies of bacteria or algae or something like that would actually self-organize in a really interesting and complex way, as they do on Earth sometimes.
Slime molds.
Really, really sophisticated slime molds, or
There's your title for the episode, Paul.
I mean, I agree with David for the most part. I mean, at least 90% or 85%. I mean, certainly we are the only complex animal life form living planet that we know about. But but see, like I said before, the microscopic life is likely, in my opinion, throughout. They're finding water. Cosmologists, astrophysicists, and or astronomers are finding water everywhere, and we're finding it here in our own solar system in places that we didn't even expect it. Now we're talking about Ganymede as well. So I mean, it seems to me that water is everywhere. So the likelihood that we are a product of that fact, I think, is a good likelihood. Of course, the microscopic life is, to me, is likely everywhere. Finding macroscopic or complex life forms, I'm talking animal life, is like David said, is a lot less likely. More in the what's the word he used? Rare side, but nevertheless, it's possible. But even if we find microbes, that would be a major confirmation in the science world.
Have we, a quick point of order, have we figured out whether viruses are alive or not yet?
No.
Okay.
They haven't figured it out. I'm not saying they're not alive, but it's just they're still kind of in that weird gray area because they're a packet of DNA that is parasitic on another cell.
Right.
They can deliver their DNA. When it goes through mitosis, it splits, ruptures, and you have more viruses, but that's still almost a mechanical delivery. They don't. So it's still a really gray area. They're basically walking the line between a rock and an animal. I mean,
it comes down to how you define life, doesn't it? And
it's
that's almost
kill them all.
Well, I mean, our prions, a prion's life, no, but they kind of they can propagate.
They reproduce.
Yeah. So.
Well, yeah, but they reproduce more like by a cascade effect. It's like knocking over domino.
Right. Well, I mean,
Ice 9.
If we
which
define
is a similar idea with the virus.
If we define life as self-replicating chemistry, viruses are not life, right? Because they require some other living thing to replicate them.
Yeah, but on the other hand, you have parasites that require other life in order to reproduce. Fleas, ticks, mosquitoes. They have to feed off of another. They have to have other life in order to do it.
Yeah, it's a symbiotic relationship everywhere.
But we're parasitic off plants and other animals. So
that's right. I mean, we have to. If we didn't have other life forms, we would die pretty quickly.
Yeah. Definition of life is you have to kill something in order to eat it. Doesn't matter. Yeah, I know the vegans say they. Nothing against vegans. Don't write Paul. But
carrots.
Oh.
Yeah. Well, here's my question to him. Have you ever?
My daughter's
heard
a tree hugger, so
celery. Yeah. Well, have you ever heard a stalk of celery scream? No, but it doesn't mean it doesn't hurt when you pull it out of the ground. I mean, in order to live, you have to take the life of something else. That's
well, I mean, you could eat fruit and nuts. They probably would not kill something.
Plants.
Eat what?
Plants don't.
Well,
actually,
I'm not vegan, but from what I understand, it's sentient being kind of thing that they're worried about. And plants are alive, but they don't apparently think for themselves. So,
Well, plants kill. You have bindweed, you've got chokeweed, you've got mistletoe. Those kill other plants in order to survive.
True.
Plants take off the nutrients of dead things that have expired. Mushrooms, fungi. I mean, pretty much anything that's alive, it somewhere or another has to take in material from another living organism. Even you look at microbes. You look at the algae that are single. I think algae that are single cell are about one of the few exceptions. But as soon as you get bigger than that, something is eating something else in some form.
Right. Something's got to be at the bottom of the food chain. Something's got to be at the top.
Well, that one is a tangent. I like that.
Well, that's really not a tangent. I mean, we're talking about, how multicellular life exists. I mean, it probably came into being as a way of exploiting and eating other smaller single cell life.
A quicker way to get
I can go off on a tangent on that if you like.
Tangents are a courage, actually, Patrick. Go ahead.
Yeah. I mean, if you think about it, if there is any vegans in here, if you think about it, and I understand the treating of animals in a nice way and all that, but if you think about it, if we all suddenly became vegetarian, I mean, outright vegans, okay, we would be allowing the animal life to proliferate to such an extent that we would not have enough plant life left on the planet in order to feed each other. There has to be a balance, and it's something. I give all the vegans, a thumbs up for their ideas, but it's just not. What's the word? It's not scientifically
feasible.
It's not obtainable. What's the word? The balance is not going to be obtained. Is not going to be kept.
Yeah, I think I am going to get mail now because I'm sure they disagree with that. Yeah.
No, I disagree.
Well, here's any of them that disagree. Not too far from where I live, a gentleman banned hunting of any kind on his property. Within about 2 years, on 100 acres, he had close to 400 deer that were starving to death.
There you go.
Well,
but if you had wolves, then there would be a balance. Or coyotes.
We've got wolves. We have coyote, but the problem is that the closer to the apex a predator is, the fewer they are in number. You're not going to have, when you have that massive concentration of deer in one location, you're not going to have enough predators big enough to capable of taking them down. A coyote really doesn't like to go for deer a lot of times because they're too big. Field mice, rabbits, something smaller than it, where the chance is less likely it's going to be injured. A bobcat,
but long before there were humans, there were these balances in nature. If you have overgrazing, if you have too many deer, then they overgraze, they starve. There are cycles. There've been cycles throughout the history of life. Human beings are not necessary. So going totally vegan. I disagree with Patrick. If everyone went totally vegan, it wouldn't make any difference to that, because that cycle is going on.
Well, back then we also didn't have sheep, pigs, cattle under our that we'd been raising and making where they're pretty much dependent on humans.
Well, that's true. But if we were to be wiped from the face of the earth, things would settle back into a routine very, very quickly.
Mm-hmm. Well, Mother Nature doesn't care.
No,
and Mother Nature is pretty cruel to animals.
Whether it's going to be run over by deer, wolves, or whatever, or run over by plant life, Mother Nature really doesn't care. So our balances and our save this particular species are really for our own sake more than it is for the planet, because the planet really doesn't care.
My teenage vegetarian daughter and I have this discussion almost every day. She's been a vegetarian since she was 6 years old, and she thinks it's just terrible that people eat animals. And I'm always telling her, well, what happens to an animal in the wild? How does it die? It dies horribly.
Well, I hope she doesn't hate me after she hears this podcast.
Normally very messily, very horribly.
Yeah,
because honestly, living and dying of old age is very rare in the wild. Normally they starve to death, they are brought down by a bigger predator, they die during mating fights. Mother Nature's a mean bitch.
Well, yeah, we had a mouse in our house the other day, and the cat attacked it. And my wife rescued the mouse before it was murdered by the cat. And she brought the mouse to me, and I said, well, okay, what would you like to eat this mouse? Would you like to be our cat? Or would you like to be the owls or the snakes or the foxes outside? And she said, well, if it's outside, I don't have to watch it. So we took the mouse outside, and I'm sure it's been eaten by a black racer or an owl since then, but
I got the feeling that a Carr family residence, a teenage Carr family residence, is going to hate me after she hears this podcast.
she wouldn't listen to a podcast that her dad does. No, not cool enough.
Yeah. If that were to happen, I'm pretty sure I would have already upset her. Don't worry about that.
Oh, I'm not worried about it. You're not a pop star. She's not going to listen to you.
But I know this is all funny, but actually, this is an interesting concept. I know it seems again it's a tangent, but it's actually has a lot to do with understanding life elsewhere. We're talking about how life, ended up being here at the present day, where we're talking about eating animals and what life feeds on other life, and we may have to start actually thinking about that. When we start, like astrobiologists and stuff, are going to start thinking about that when they find another planet with life on it and try to figure out how the cycles work on that planet. We haven't figured it out here yet ourselves, so it's going to be a long, drawn out, learning session. But nevertheless, it's important that we think about these things.
So you think that when we go to Europa, we should take a fishing rod?
Yes.
Yeah, as long as we get the scungio or the calamari. Yeah, how do you say alien in Italian? The alien calamari.
Fishing rods and a grill.
German. Alien in Italian.
Well,
I just want a tauntaun. That's the reason I want to go to Europa.
Why, for fish?
You know what? I would.
I couldn't hear you, David.
I would be willing to take the bet that there are fish down there. Well, not fish that we would recognize, but something that can move through the water efficiently and is multicellular.
I'll take that bet.
I mean,
I won't bet on it, but I'm like hoping for it. It's like it would be the most exciting thing that ever happened to the human psyche.
Yes, it would.
I bet you a bottle of wine, a bottle of Australian wine.
Oh, I like Australian wine. That's you're on. If we both live long enough. Could be neither of us.
Might have to be a bottle of
the reason I think there might be fish is I think that the history of life on Earth is the only history we have to go by, and it's been a history of increased complexity and diversity. So, and even the bacteria and the single-celled organisms we have now are very, very sophisticated. Mm-hmm. So they've evolved a long way, and so I think that we could well see multicellular organisms. Now, I'm not convinced that the eukaryotic transition is that improbable. In fact, I think it may. I don't know if I'd use the word inevitable, but not that improbable.
It took 2.5 billion years to happen.
Yeah, as far as we know, it took a long time. Yeah.
So you had 2,000 million years in which there was no eukaryotic life. So that tells me something.
Well, I think that, it takes a long time for I think the basic biochemistry of life to evolve. Once it's all in place, things can get more interesting, especially that was right around the time when we started to oxygenate the atmosphere. So, and oxygen, and for animals, well, even single-celled organisms to live off of oxygen, they had to get a lot more sophisticated. They had a lot more complex, and that was the selection.
Isn't that when you had the Cambrian explosion? Isn't that?
Well, that was later.
Wasn't that associated with? That was later. Okay.
Quite a bit later.
Yeah, it was 200 million years later, after we began to have oxygen in the atmosphere.
Well, it was about I'm going to remember here about 600 million years ago that the Burgess Shale shows all this complex life. And
on a side note, I saw a documentary once that talked about the amount of oxygen that was in the air compared to what it is today. It's actually less, according to this documentary.
Yeah, that's why insects were bigger.
Animals, like the dragonflies that still live today were 3, 4, 5, 7 times larger than what we have today, and it was due to the amount of oxygen in the air. That's the
right. Yeah, the arthropods, the insects, were enormous because they breathe through spiracles in their sides, and it's not the most efficient form of respiration. Plus, they don't have like lungs like we do. They breathe in, it just goes straight into the body fluids that they have. When they're back then, and this was always fascinated me. I used to want to be a paleontologist when I was a kid. So I read a lot about it. But yeah, the oxygen content was, just off of memory, I think they said it got as high as like 70%. And that enabled the larger, that enabled the, 2 and 3 foot long millipedes, it's 4 or 5 foot millipedes.
70? Did you say 70%?
Nope.
Yeah. Well,
I don't think
at one point when it. Well, like I said, I'm running off of memory from 30 years ago too.
We'll check that.
But yeah, I'm trying to find it. But the oxygen content was much higher, which allowed for much larger insect life to evolve. There were dragonflies the size of birds.
I think it was in the order of single-digit percentages, possibly, 10-ish, 12-ish percentage digits higher. But
it's more than 20 now, right? So
yeah, that's right.
Yeah, it's 21% now.
What are we now?
Yeah, about 20.
It's 20 odd percent.
Yeah, so I think the documentary mentioned a possible 30. Or 28 or something, in the order of maybe 10% higher or 15% tops. I don't remember the exact number, but certainly not 70%.
You'd have fires. If it was that. A fire would just get wildly out of control.
Yeah, I mean, fire would just be spontaneous at that point.
Well, see.
I'm seeing if I can find it.
Well, it's a geological history of oxygen I'm looking at.
Okay, 35.
It's still a lot.
35% is about where it peaked. And that was pretty recent.
I'm good at my guesses, aren't I?
That was pretty recent. That was, about 300 million years ago?
Into the Carboniferous period, about 300 million.
Yeah, so for a
long time... Excuse me while I go
pat
pat myself on the back for my
yeah, for a long time it was 0, and then it went up and flattened out.
I am entitled to one blonde statement per episode.
Okay, now, nobody's had a rant yet, so you guys can start your rants now.
We'll let Andrew, because he's the newbie.
Well, I was just thinking, I don't know that there's anything to rant about on this subject unless you're going to get into the political funding of it, because it's so interesting. It's so exciting to be going these places and seeing if there's seeing what there is. We want to dig in. I think we're by nature, as humans, we're explorers, and we've figured out kind of what's on land. We've got 2 places left. It's out and down, and so it's such an exciting it's such an exciting time to be alive, to see this development of exploration of outer space starting. I'm just really excited about it.
I'm excited about that. I mean, we can't look at one subject. I have some layman people out there that say, "Oh yeah, we got to go to Europa," and that's all they're focusing on. Forget about Mars. No, it's all of it. All of the science is important, including the mapping. Since Kepler went up, it's like if there is ever going to be, and as far as I'm concerned, there is no warp drive. But let's just say that in the far future, there's going to be people traveling to other stars. The Gene Roddenberry's mapping of the galaxy, knowing that not just that there's this particular class star out there, but what planets are orbiting it, has started. Our new era of mapping the galaxy has started. In other words, we're not just knowing the stars; we're knowing what type of planets might orbit them, and that's the ones that they're going to go investigate. We're learning about life and how proliferation, of life is by studying our own solar system and sending out probes to study, Europa, Mars, etc. These things have to go together. And it is, you're right. We are living in an exciting time. Some people say we want to be, 100 years from now, but you know what? We're the writers of what's going to be in the future.
I can only agree with what Patrick's been saying. I think it's a very exciting time to be around. There's even right now, just these next couple of years, there's some very interesting things happening, and it'll be interesting to be around and find out what is out there. So it's a great time to be around.
Yeah, I agree. And go ahead, James.
I was going to say, well, what I was going to say is completely pointless because I pretty much agree with what everybody has said. It's all the information that we've got coming is going to be fascinating. And yeah, I do agree with Andrew that we do need to put more funding towards it. If we were to just maybe trade in a couple of tanks, we may be able to afford, give some more money to NASA.
Yep.
Just trade in the F-35, and we could do everything: Mars, Venus, Europa, so this.
But I like those too. Those things are awesome.
Yeah.
Yeah, but I mean, well, then what's the new one that's coming up that's got so many problems? Is it the F-22 Phantom? It's got so many problems.
F-22 and the F-35 in terms of cost.
The F-35 is the one.
Performance. Yeah.
Yeah, it's not as maneuverable. I mean, an F-16 can apparently fly circles around it. That's the last what I heard.
Yeah, well, there's issues with all those. We seem to go in cycles. Maybe someday I'll do a show about Boyd, the guy who was the major pusher behind the F-15 and X-16. But and the guy who invented the OODA loop. What I would I want to point out that my view is that Europa is great, but we shouldn't sacrifice Venus and Mars to go to Europa. We should. I mean, the amount of money we're talking about is a tiny percentage of the federal budget. It's not even 1%. And yes, it will be very expensive to go to Europa. It will cost a lot of money. It will take many years. But it's compared to what it costs to prosecute a war in the Middle East, it's chump change.
Fair enough.
we could have paid for it with a couple of months of Iraq. So
possibly better long term.
So it's a question of national priorities. Not that we shouldn't keep an eye on some bad guys that are out there, but nation building just costs too much. Maybe planet building is a better investment.
A lot more speed.
But you don't get to blow stuff up.
Well, we can do that too. You can blow up asteroids all you want.
Yeah. Well, I know a lot of military guys.
Geopolitics. I mean, if we could just stop the nonsense. I guess you guys seeing my bio understand that I'm an atheist, and it seems to me that all wars are created through religion. If one of these days, and it may not be in my lifetime, although I'd like to see it before I turn 90, we are going to realize that we are all human, and we need to figure out how to survive and change and learn. I mean, the biggest pain in the ass on this planet right now is coming from the area on this planet which actually gave us our numeral system, the Arabs. We have an Arabic numeral system. That's where science used to be done thousands of years ago. I mean, it's ridiculous to think that they turned into something that is completely different than what they were. So sooner or later, we're going to have to get together and realize that, over eons of time, we've all had our pluses and minuses, and we need to stop the nonsense and become a global society. I don't think it's going to happen in my lifetime, but I'd like to see the start of it. And that is when we're going to say, well, there's where the money is going to come from. That's where the effort is going to come into exploring the rest of the universe, or at least our neighborhood of galaxy.
Okay, I think that's
Maybe
a good place
we've
to.
used up all the oil.
Sorry, James, I couldn't hear you very well.
I said maybe when we've used up all the oil, we can start. But as long as there's oil in the ground, it's going to be a.
Well,
there's too much money.
I think that. I don't think the oil's going to run out anytime soon, but I think that it's going to become a lot less valuable. We're getting better and better at renewables. The cost curves keep going down. So,
that or they're going to do like they're doing here in Oklahoma and just shake us all to death.
Well, I think my next car is probably going to be an electric car, and I just bought what I think is my last gasoline-powered vehicle. And I think a lot of us are going to have that too.
On the other hand, the internal combustion engine is really good when you put your foot to the floor.
Well, people who've driven a Tesla tell me that it's awesome to drive.
Yeah, I've heard that too. I want to try one.
And they're
but
coming
you
out
don't
with
get that roar.
Yeah, but it doesn't make that noise, man. That cool noise.
You know what? We can make that virtually possible. You can have any noise you want when you step on the gas.
I want a duck.
I want Wagner. Da 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 da.
That's not bad. I'd go for maybe TIE Fighter.
I was getting ready to say TIE Fighter.
Or the voice behind you that says, use the Schwartz.
Yeah, there you go.
No, the TARDIS. Every time I hit the brakes, I want to hear the TARDIS noise.
Yeah, that's right. Wasn't Doctor Who accused of leaving the brakes on by what's her name by
River Song?
Yeah,
River Song.
Okay.
That's because you always leave the brakes on. Huh? Yeah, we're going way
This is just getting silly, people.
Hey, Paul.
So I'm going to turn up the music a little bit.
All right. Well, this is a fun format you've got. You let us cut loose. I learn a lot because, as Patrick said, I'm a layman too. I read a lot and stuff, but I'm a farm boy. I mean, that's what I do.
Well, I'm the son of a farm boy.
Other things,
well, I'll tell you what, you had some good info for us, James, so you did well.
Yeah, sorry about the informational error on the oxygen content 300 million years ago.
Well, I remember that very well, and I think there was, about 35%.
Well, if it wasn't for you, farm boy, I wouldn't be eating properly.
That's true. Okay, I'll tell you what. Any last words from anybody on at least a halfway serious note? If not,
I'll be serious.
If not, I'll go ahead and say goodnight to the good people.
It's a hard switch, man. No, I think we've pretty much covered everything.
Yeah. Well, there will be lots more of these. This is episode 10 of the Unseen Podcast on the 12th of June, 2015. And I'd like to thank you. If you've listened all the way through here, thank you, and what's wrong with you? And no, we appreciate it. And if you have questions, comments, corrections, you can go to unseenpodcast.com and comment. You can find us on Twitter at Podcast Unseen. You can come over to our Google Plus community. There will be a link in the show notes. The show notes will be at unseenpodcast.com. You can also email at unseenpodcast@gmail.com. And if you would like to be on the show as a panelist or as a special guest, because you have some marvelous expertise you'd like to share with us, and let's say astrobiology, we'd love to have you. Really, seriously, we would. Email unseenpodcast@gmail.com. You don't have to explain your psychological problems. Just send us an email saying, hey, I'd like to be on the show, either as a panelist or whatever, and I'll tell you how you can get on the show. We are expecting in July to have a science communicator and astrophysicist Brian Carberline on the show. We're looking forward to that. We're trying to get an astrobiologist actually to appear next month as well. So looking forward to that. You guys should come over to our Google Plus community, contribute to our topics, and appear on the panel. So please go to unseenpodcast.com. That's the last time I'll say it. And let us know what you think. And this has been episode 10 of the Unseen Podcast. Good night.